Hello, my name is Dimitro, and today we're going to be doing number 4 from the review problem. It says let D be the region bounded by the cone z equals square root of x squared plus y squared, and above the paraboloid z equals 2 minus x squared minus y squared. And for part A, we got to sketch the picture of the solid, which over here we already did. We first sketched the paraboloid, which was 2 minus x squared minus y squared, and the cone, which would be I guess under it, which is z equals x squared, or square root of x squared plus y squared. And for part B, we have to write the triple integral needed to calculate the volume of the solid in order of dz dr d theta. But thankfully we don't have to integrate. So first we wrote down our z's, but as you can see, our transformation r squared equals x squared plus y squared, we're able to substitute this part right here into r squared. So we'll just have z equals r squared. And for the cone, which is z equals square root of x squared plus y squared, will be simply just z equals r. In that case, we would be able to write down our triple integral, which is for the z bounds would be r from r to 2 minus r squared. But now we gotta find the bounds for r, where we'll simply just set them equal to each other, which is just r equals 2 minus r squared. If you move it around, you're able to get a quadratic function, but you end up with r equals -2 or r equals 1. But in this case, we'll only use 1 because we're only looking at the region above z equals, or z greater than or equal to 0. So our bounds for r would be 0 to 1. And then for theta, it'll be simple. Since we're covering the whole region of the cone or the paraboloid, we'll just simply be 0 to 2 pi. Now for part C, we have to write the triple integral in terms of dr, dz, d theta, which is a little more complicated. But similar to part B, we would say we'll solve for r for both z's, which is r squared equals to 2 minus z, and from there we get 2 equals plus or minus square root of 2 minus z. And for r would just be r equals z. And to find our z bounds, we'll just set them equal to each other, and we'll get the same thing as we got for r over here, which is just z plus z equals -2 or z equals 1. So, but in this case, we need 2 integrals, because as you can tell over here, I mean 2 triple integrals, because as you can see over here, the region changes from the, where is it? Oh yeah, from the paraboloid to the cone, and the cone to the top of the paraboloid. So our first triple integral for our bounds, our r would be from 0 to z, since we're starting from r is always from the origin, so 0 would be here, and our r is the cone. And then our z would be 0 to 1, which is this layer right here of the cone. And our theta would be 0 to 2 pi, same thing, plus our other triple integral, which is our first bounds for r would be 0 to 2 minus z, or square root of 2 minus z, because if we solved for it, where was it? Oh, over here, right here. We used a plus since it's positive and z equals 0, right there. And for our z bounds, we're going to use 1 from our last one, and 2 because 2 is the max limit that the paraboloid reaches, so it'll just be 2 to 1. And our theta would be 0 to 2 pi as well.